Let's continue our work with similar triangles. We are told in the first example that the triangles are similar. The figures are similar. Find the missing side. So we need to solve for x. And whenever we know that triangles are similar, we want to look for a relationship in the corresponding side lengths. So I typically look at the long slanted side, the 7 and the 16, and I might say to myself, what's the scale factor? What do I multiply 7 by to equal 16? But that's not a convenient number, is it? So in that case, instead of writing a proportion that starts with 7 over 16 equals x over 8, what I think I'll do instead is look for a relationship in the two sides of each triangle. I'll notice that in the larger triangle, 8 compares to 16 because it's 1/2 of 16. So I can write a ratio or a proportion that looks like this. 8 over 16, that ratio in the larger triangle will be equivalent to the ratio of x over 7 in the smaller triangle. And 8/16 is another name for 1/2, right? So I would then ask, what number would x have to equal? What number is half of 7? And that would be 3.5. You might also just show the division that x is equal to 7 divided by 2, because that's the relationship that's existing in those sides. So x is equal to 3.5 or 3.5. Now let's take a look at the next example. It says triangle PST, so that larger triangle PST is similar to triangle MQL. And once again, when I'm solving for x, I see that x corresponds to the side that's marked as 40. But then I look at the other corresponding sides and I don't really see a relationship. I don't know off the top of my head 8 times what is 20. I don't know off the top of my head 12 times what is 30. But I do see in the large triangle, there is a relationship between the longest side 40 and the shortest side 20. 40 is double 20, right? So I can write a proportion that says 40 over 20 in the big triangle is equal to x over 8 in the little triangle. And now this is not something that I need a calculator to solve. I could use a calculator. I can just spot the relationship is the numerator is twice the denominator. 40 is twice 20, and so x would have to be 8 times 2. X equals 16. So we just want to point out that while cross products are helpful and good and valuable, sometimes you don't have access to a calculator, and so you want to look for another way of making sense of these problems to solve for the missing side. We have 2 examples here, and we would really actually love for you to put the video on pause now and solve these problems on your own. Grab a sheet of paper and write down whatever you need to write down. Remember, we are looking for multiplicative relationships, right? Not additive relationships. We're not saying 3 plus 9 is 12. We'd say 3 times 4 is 12, something like that. But you could also use proportions. All right, pause the video and then come on back. So in this case, I actually wrote a proportion where I set the corresponding sides, the ratio of corresponding sides equal. And I said 3 over 12 is equal to x over 18. And then I decided to use cross products. So I multiplied 12 times x and set that equal to 18 times 3. 18 times 3 being 54. Now I did use a calculator. I divided both sides by 12 and I got that x is equal to 4.5. I always take my answer and I look back at the picture and I think, does that answer make sense? 3 is the short side on the left, 4.5 is the base, and then in the other similar triangle, 12 and 18. Answer makes sense. How'd you do? Did you solve it the same way or differently? All right, so now we're going to look at the other problem. I'm curious how you solved it. Again, I set up a proportion and I set the ratio of corresponding sides equal. I said x over 6 is equal to 20 over 8. I once again cross multiplied and I got that 8x is equal to 120. I grabbed my calculator, I divided both sides by 8, and I got that x is equal to 15. How did you do? All right, we've got one last problem for you here. We have two triangles. We are told that these triangles are similar. So they're right triangles. One is just a scaled up version of the other. And when we think about similar triangles, when we think about the word scale or scaled up, what would I multiply? Always a multiplicative or dividing relationship. What did I multiply the short side lengths by on the triangle on the left to get the corresponding side on the right? So I can see that there's a scale factor of 2 right there, right? So because of that, I feel like x should not equal 12 like what it shows here. I think x should equal 20 because it should be 10 times 2. So we are asked to describe and correct the error. So let's take a look at the first statement. 8 over 16 is equal to 6 over x. Well, I think that's the first problem. 8 over 16 is going to be height over height, but 6 over x is not base over base. So because we're solving for x is the hypotenuse, our ratio should be height over height is equal to hypotenuse over hypotenuse. 8 over 16 is equal to 10 over x. Now I can look at those fractions. I see that the denominator of 16 is twice its numerator. Therefore, x should equal 10 times 2. And x will equal 20.